Hey everyone, I have plans on building my own DIY solar power station, and that's what this piece of plywood is right here. This is a 4 by 2 foot piece of plywood, and I'm going to attach all the stuff on here. In this video though, before I go ahead and make that project, and have that video pretty soon, I wanted to test out these two components right here just to make sure everything works. And what this is Renogy sent me this 100 amp hour lithium iron phosphate battery right here. It's a self-heating battery along with the 1000-watt power inverter. Everything else in this build I bought myself. I decided I wanted to go with all Renogy. So I've got this charge controller right here that I purchased. I got the solar panel I purchased. I want to do it all the same. So in this video, I'm going to test these out with a few different things that might be useful in a grid down situation in a power outage for preparedness. A water filter and a couple of other things. So what I want to do is I'm going to move this tablet out of the way, and then we're going to test a few different products with this. The first one I'm going to do is just this little tiny space heater. Let me get this out of the way here. And I purposefully chose some items that would be useful in a preparedness situation. So the first one I've got here is this little cheap 400 watt space heater that I got from Walmart, and honestly I wouldn't suggest anything like this. This is one thing you want to get a good quality product. This would be useful. The 400 watts is great, but the fact that it's a Walmart brand, I'm just not sure about the quality of it and all that. But let's go ahead and plug that in. First, I'm going to get my watt meter right here, plug this in, and that way we can see what this is actually pulling. So let's turn this on. And it's ramping up here. And on this inverter, it's pulling about 400 watts, pretty close to 400 watts. Now this little heater right here at 400 watts, I'm going to test this thing out later, maybe a higher quality brand, but to heat a small room like the one I'm in now, this would probably do pretty well because it kicks off some pretty good heat at just 400 watts. So this would be that emergency small room type situation, which would be good, and having just a 1000-watt inverter would be fantastic. Now if you bump this up to 2000-watt inverter, you could get yourself a 1500-watt heater, which would be fantastic. So at any rate, so this is running at about 300 watts right now. Pretty good. The inverter the fan hasn't kicked on or anything. Not anywhere near the max on here, but it's running good. So let's go ahead and try our next one, which is the Pure water filter that I did a review on in the past. We'll put this right over there. We'll plug this sucker in, and I will put the water tank on it. And it's telling me to put the water tank on, so we'll grab this water tank right here, put that on it, and now it is going to fill up that inner tank. And what's cool about this water filter is it only takes about 40 watts to run. So this is, pretty low on this. This water filter is fantastic. It's a reverse osmosis water filter, and in a preparedness situation where you've got questionable water, this thing is fantastic. It's a little bit loud, but it works great. It's going to work better than a Berkey or any of those. So I really like this, and the fact that it runs on such low wattage is perfect, because you're not going to use a lot of power to filter water with this thing. Alright, so while that's still running, we'll go ahead and just do a little bit of water here. And then that is the wattage actually went down as it's dispensing the water. which is pretty cool. And then as it kicks back on, you've got your wattage going back up to 25. I've seen it go up near 40, so pretty cool. It actually works for the water filter as well, which I figured it would. It's really low wattage, but something that would be nice and super convenient. Okay, so let's try the next one here. Get this out of the way. And we've got this ice maker right here, which you might not think is one of those life-saving supplies or prepping supplies, but it's actually, let me move this into the picture here a little bit more. This is actually pretty cool because in a grid down situation, it's not always worst case scenario disaster. And a little ice maker like this, if you are drinking warm water, room temperature water, having something like this is going to be, it's going to be a luxury. Not something that you absolutely need, but having a little ice maker like this could be something you'd use quite a bit. So let's go ahead and plug this sucker in, and we're going to have to pull this up because of the cord. But we will turn this on now. And what I'm going to do is just let this run and make some ice. And on this, right now we're using 1 watt as it gets going. We'll see how it does once it starts doing the ice and using more power. We'll see where it goes. So right now we're using about 85 watts, which is not bad at all. Another cool thing with this battery monitor right here, you can actually, it will tell you, so right here it will tell you that 12.8 hours, and this is, again, it's 74% full, but 12.8 hours I can run this machine, which is going at 83 watts right here. So it'll give you the information you need, and whatever load you have on there, you can measure how long you're going to be able to use that. Alright, so now looks like it's getting ready to drop the first batch. And this takes about 7 minutes for this to complete one little batch of ice, which I believe is 8 cubes. And it takes about 100 watts to run this. So for basically, it takes about an hour, a little bit over an hour to fill this whole tray right here. So basically, 1 amp hour, you can fill this whole tray. So it doesn't take a lot of energy. And I'll tell you what, if it's hot in the summertime, the power's out, this is going to be something that you're going to want. Granted, you've got the freezer, refrigerator, but if it's a few days, I'll tell you what, you pull this thing out, it's going to be fantastic. So one last thing I tested with this as well is in my harvest right, I did some eggs. And I blend what you do with the eggs. You scramble the eggs, you freeze dry them, and they're raw, and then you put them in the blender. I tested this out in the blender, and with this 1,000 watt inverter right here, ran it. It was only it only used about 350 watts, and that is a 1,200 watt blender right there. But it was on low mode. Even on the highest mode on that 1,200 watt blender, it only reached like 600 watts. So this handles that just fine. Not that you would need a blender in some sort of disaster type of situation, but you never know. This little watt meter right here is fantastic to be able to tell. Just because something says that it's 1,200 watts doesn't necessarily mean it's going to pull that much. So having this right here is, and I think this was like 15 bucks on Amazon, is a great way to just figure out what sort of energy you're using. I use this mainly for my harvest right to figure out how much during the month, how much energy, how much it's costing me to run the harvest right, which it averages about $3 a batch. Totally different video, but at any rate, it runs all of these as long as you keep below this 1,000 watts. The fan never kicked on. I never really juiced it really high or anything like that, but as long as you keep it below the 1,000 watts, this is going to run whatever you need.
More power.
So now to test this out at its full capacity, I'm not going to run this for very long, but I'm going to see after about a minute if this will still run. This hot plate is 1200 watts, so I don't expect this to be able to handle it, but we are going to test it out and see. So I will plug that in there, and then we will just crank this on to the lowest setting and see what sort of wattage we are getting from this. So right now we're at 1066, 1069. So we're right above what this is rated at. And I assume that being just like this, it's going to be fine. Let's see if we kick it up a little bit, if that goes up. We're at 1075. So we're getting close to 1100 right here. If I crank that to the max, we're still right around that 1068, 1050 range. So this is doing just fine with that, and it's been, longer than 30 seconds or so. So you could, in an emergency, probably power this little hot plate right there. For me, I'm not going to go over that recommended rating because I just don't want to damage the unit. So I wouldn't want to use something like this all the time. I would want to kick up to a larger inverter. So I'm going to go ahead and turn this off now. So as far as from a preparedness perspective, I wanted to use that as an example because something that's a lot of the appliances that you have are going to be higher than 1000 watts. Coffee makers can be, refrigerators are far lower than 1000 watts, so you could run a refrigerator on a 1000 watt inverter and this battery. But from a preparedness perspective, this is good for a lot of things. But what you really probably want would be maybe 2 of these 100 amp hour batteries and a 2000 watt inverter, because in your home, your typical wall outlet is rated for, if it's a 15 amp fuse, it's rated for about 1800 watts. So basically anything you'll plug into your home is going to be less than 1800 watts. So a 2000 watt inverter would be great. You could get a 2000 watt inverter with just one battery, but you still can't go above that 1200 watts like I explained earlier. So you would need 2 batteries to get up to that 1500, that higher wattage, those higher wattage appliances. So just know what you have and what you can do with it. Sort of size everything out before, so you know exactly what you need, basically. Now, with this kit, now that I've tested this out and everything works great, I'm going to take this piece of wood right here, and I'm going to take all the components. I've got all the fuses, I've got the switches, I've got the charge controller, which is right over here, and this is hooked up to one 100 watt solar panel right now. Eventually that's going to be kicked up to like 240, 250, which is why I got this large Renogy 30 amp charge controller right here. And I've also got the BT1, which is a monitor, basically. Let me see if I can pull it up on my phone here. A monitor that just tells you the state of your battery and everything. So if you go into the phone, you tap on that and it will tell you your battery information. Right now it's charging at 2.48 volts, so the sun must be peeking out a little bit because it's colder than heck outside. And this just gives you all the information of your battery. The 100% state of charge, you just ignore that because it's not going to give you correct readings. That's why you would need to look on the other one. But I'm going to go through the whole setup, all the different wires I needed, all the different connections and all that stuff in the next video. So watch for that. If you do have any questions about these products right here, the Renogy 100 amp hour smart battery with heating function, the 1000 watt inverter, even the Rover right there, which I'll be doing a separate review on later on. But just Renogy's got some really, really reliable products, and you're paying a little bit more than some of the cheap stuff, but you're getting reliability. Like I said, from what I've seen, the videos I've watched, this is a really high quality built battery and a really good battery. So for the price, you're getting reliability, and that's exactly what we want in a SHTF or a survival situation, disaster, grid down situation. We want something we know is going to work, and that's what Renogy offers right there. So at any rate, like I said, I'll be doing the next video with my DIY solar charger setup. If you have any questions about this or any suggestions as far as the next video and all that, let me know. But until next time, take care and prepare, everyone. We'll talk to y'all later.